Alrighty. Our next speaker is a Seattle local that has been a full stack developer for a couple of decades, is a developer evangelist at Algorithmia, and is psyched about the changes that they've seen in the developer ecosystem over the time that they've been a part of it, and is here to speak about using APIs to supercharge your applications. Everybody welcome John Peck.
Hey, good to be here. Do I have visuals? Yay! Okay, cool. So you heard who I am. You don't need to know more about me. I've been around for a little while. I hesitate to call myself venerable because that implies some kind of wisdom. I'm mostly just starting to think of myself as old at this point. But I have seen a lot of changes in the ecosystem, which has been really cool. So you've probably all seen at some point this definition of a programmer, an object capable of turning pizza and caffeine into code. But we are oh so much more, right? Among other things, we are judicious with our time. We are occasionally lazy, and we don't feel like rebuilding the wheel when it's already out there in a form that we think is pretty good. Sometimes it's a fun exercise, but most of the time you're looking to get the job done. And so you are looking out there to find some kind of API or library, hopefully, that's going to help you along. Now, when I started, an API had kind of a different definition. It's Java Standard Edition, right? Version 6, I started much, much earlier. But it's a definition of just all the functions you got available in your library, what they're going to do, what you expect back from them. Nowadays, most of the time when people say API, they really mean REST API. They mean a remote API, something occurring out there on an endpoint on some server somewhere. Okie dokie. So these, at first blush, seem to be pretty different, right? One of these is actual code that runs locally right there in the browser. You're doing something with it. The other is out there in Never Never Land. You've got to run it through JSON to go and call it and get it back. But realistically, we use these things very similarly. They just have very different operating characteristics. So let's dig into that. Before we go further, just a quick reminder of what we expect out of a remote API, right? It's client-server. So there's someone who's consuming the API. There's someone else who's actually providing the API and doing the work. It's usually stateless independent, and it's, generally speaking, platform agnostic. So it's going to accept and give us back either JSON or XML, JSON a lot more often nowadays. And so you can use it from just about any environment, whether that's command line, just doing a raw curl, or whether that's actually doing it right inside your browser, inside a micro library to call it for you. They are sometimes discoverable. So the pain and suffering that we've all had at some point of either having to dig through web pages or even worse, go to the library and find that book that actually has the API listed somewhere for some library we're using, right? Nowadays, there's things like Swagger, which will allow us to programmatically discover and understand how an API is structured. That's great when you find it. In reality, it's still usually finding some web page somewhere that's going to describe this API that you're going to be using. And if we're lucky, also scalable. Because what I really love is for when my application goes viral and suddenly it's not just me and my mom using the cool thing I built, but a million users out there on the web, that it doesn't crawl to a halt because some server I'm depending on somewhere for some information or calculation doesn't scale properly. So that's one thing we're going to keep in mind as we try to figure out which APIs we're going to use. A quick overview of the difference in characteristics, right? Libraries, big footprint, right? None of us want that experience. We talked about it a little bit yesterday, of I go and I load up some website and then I wait for 15 seconds while it pulls down all the frameworks and libraries I need, and then I finally get some response. You can deal with some of that with asynchronous loading, okay, but then you get herky-jerky on your web page and all kinds of other problems, right? The trade-off with APIs, there's no delivery footprint, but you do have to deal with increased latency. Now, usually that's not bad. Nowadays, we're talking under 50 microseconds in many cases for most APIs to return. So unless you're doing a whole lot of those hits, your user is really not going to notice the difference so long as they're on an okay network. Modulo, antenna warm-up time on your cell phone, right? Execution, local or remote, what can you take advantage of? One of the pain and suffering points is that there's amazing hardware available in this. There's high-intensity GPUs that can run machine learning algorithms that'll do all kinds of stuff. I don't have access to those from browser-based JavaScript. I can't take full direct advantage of that GPU to really do high-intensity processing. So there's times I'm just going to have to ship it out somewhere else. And of course, if I'm in the browser, mostly, obviously this is changing a bit, cool stuff coming down the line. But right now, most of the time, I'm locked into writing JavaScript if I'm going to run over the web on my browser and not have try to build down to a native app, for example. Your setup time is increased a little bit with libraries. You've got to learn it, but then you've also got to resolve any dependencies. You've got to integrate it with your current code base. Generally speaking, an API, you're just making a simple call, easy and fast to learn, although sometimes the parameterization gets a little weird. And then cost. So one of the things we tend to balk at sometimes is the cost of actually going and calling that API. So usually there's like a small per unit charge or something of the sort. Okay, good. No one freaking out? Okay. But you have to contrast that, too, with the cost of actually setting up that library in your own system, doing the maintenance, pulling down and integrating new versions, that sort of thing. Those have a time cost to you. So you've got to balance what your project is for and how it's going to work. And then, of course, risks. So that library changes, dependencies changes, other things change. You've got to resolve those. You can do that, but it takes some of your time. Versus the risk of that API provider going down or simply going out of service, period. Then you have to suddenly hurry up to find somebody else. A quick side note here. You can call most APIs directly from JavaScript. It's really not very bad. When you get into other languages, that direct call gets a little bit painful with more setup for all your header options and that sort of thing. Once you start getting into edge cases, you're doing lots of binary transfers, that kind of thing, it can actually get really messy. So you will find that API providers still sometimes will provide you a tiny little JavaScript library that you can just dump into your app. And that's more or less just going to wrap up all of those calls for you, make it nice and easy, so you can focus on transferring just the data you need and not think about the other characteristics of the API. All right, so what can we do? There's some things we have to do with APIs, right? We just can't do it locally. If I want to access somebody's Instagram account, if I want to log them in with a Twitter or Facebook login and then go monitor their feed, or I want to, say, inject data into my company's Slack feed, all of that requires I go and access some API somewhere because it's all remote stuff. Even when it's not specific to one service, often we still have to use a remote API, but we have our choices, right? So if I want to make a credit card transaction, I can use Stripe or PayPal. If I want to go and get weather data, I can get it from NOAA or I can get it from OpenWeather, okay? These are all available. You take a look at them, you decide what fits best, what you need in terms of information, and what you think is most reliable and most fits with your ethic, and you go with that one. But you can't just have your local phone figure out what's happening in the world in terms of weather. It's obviously not possible just locally. But there's also things that we could choose to do locally or we could choose to do remote. And sometimes we want to think about the decision carefully, right? So yeah, if I want to do logistic regression in the browser, I can. It's possible. There's JavaScript libraries out there for it. It's time intensive. It's going to slow down my app. Shipping that out to another provider to do it for me and then give me back the results, even though it's actually a relatively simple routine, I could code it from scratch, it's actually just going to be more efficient for me to outsource that to some server. And then there's other times where for other characteristics in the cloud processing matters. So for example, if I want to do site mapping, right? Not something we do a ton of now, but it's possible to do site mapping from just within the browser itself. Sure. But as soon as that server sees 1 million requests per minute coming from one particular IP address, the denial of service protection is going to shut it down and it's going to stop working, right? Put that out into a cloud-based provider where you can shard that execution across a bunch of different servers, a bunch of different IPs, and you circumvent that denial of service protection problem, and you're able to actually acquire the data you need in reasonable time, multiplexing the results and getting them back fast to your client. Great. Okay. And I want to talk briefly about machine learning. This is a particular interest of mine, right? Now, machine learning is possible in the browser only, as long as you only want very specific cases. There's a couple of libraries out there, MLJS for one, which are kind of cool, and they'll do certain things, but they'll do them relatively slowly. Again, I mentioned we don't have direct access to the GPU for now, for example. So there's lots of cool things we can do by accessing machine learning-based APIs. For instance, sentiment analysis, right? The user types something in a comment form. You can tell that they're angry before they even send it. So you can right there in your application, in your browser, be offering them helpful suggestions before they start going and just harshing on your help desk, right? You can transform images. I'm going to show you some automatic colorization stuff in a minute, which is really kind of cool, where you can take a black and white image and it just figures out what the colors ought to be in that image without knowing anything else about it. Now, machine learning is especially well suited for the cloud for computational reasons because of the size of the data, but also because of this concept of models as a service. So when you do machine learning, basically you're building up more or less a statistical model to solve some problem, right? So I'm going to say, okay, hot dog, not hot dog, right? Yeah, okay, good. I got a little bit of a laugh out of you. So what I'm going to do is I'm going to show my machine learning algorithm a bunch of images of a hot dog and a bunch of images of, let's actually pick something specific, otherwise a hamburger, right? And those are labeled. I say, these are all hot dogs, these are all hamburgers. The machine learns over time, and eventually it gets to the point where you can give it another image and it'll be like, that's a hot dog or that's a hamburger. Okay, great. So that's not that hard to do. What is hard is building up the data set, sourcing all the data, labeling it, going through the time required to train that model. That can take days to years, depending on the complexity of the thing you're trying to do. So when you're using a machine learning API out there that someone else has built and trained, you're not just utilizing the processing, you're utilizing the result of their efforts over days, weeks, years of getting that right data set and tuning the model the right way so it's actually going to behave well. And I think this is really an emerging sector in our field in general, that this sort of like taking this knowledge base that you've built up, turning it into something usable by other people, and then putting it out there for folks to use, not just as an algorithm, but as a built-out data-based model, is going to be a really powerful growth area. And, of course, you can also do that yourself. You know, maybe you spend that time, you're a data scientist, you go through that training, you come up with something really cool, and then you want to put it out there and make it usable, perhaps by you, perhaps by other people. So these are both cases where an API is totally appropriate. Okay, let me show you a few cool, I think, examples of things you can do with APIs. So what is nifty about these is all of these demos, with one exception, which I'll explain in a minute, are called entirely from the browser. I've not written a whit of server-side code for any of these, right? So I'm just making very simple API calls from here. All the code in here, none of these are less than like 200 lines of JavaScript, and that's basically just manipulating the UI, right? So I can take an image here that I've got. This is initially a black and white image. It knows nothing about it. Boom, that is false color. That's been added by my machine learning model, right? Okay, so that's pretty powerful, but why don't we apply that to an entire video? So here I've got a black and white video that my machine has never seen, my model's never seen. I go ahead and I run the colorization. There's a few bugs, there's a little bit of flicker, but mostly it gets it right. It's fast, it all runs in the cloud, but I can display through the beauty of HTML5 video that result directly in the browser. I can go further with that with all kinds of different things that are available, like, for instance, saliency, which is an algorithm which tracks objects in the frame. Oop, that's deep filter. Okay. So it's going to see what's most important in the frame at any given point in time, and it's going to try to track it. Sorry, my video's gotten out of sync there, but you can see it's following the skateboard. And I can do more and more fun things. Like I can, for instance, there's a model out there which tries to identify car, make, and model, right? So I can give it this video of this vehicle. I can go ahead and extract that meta information. It's going to build it out. And then I can do something like I can toss it into timeline.js. So now I can look at that video, and I can just click right here where it says, this is a hatchback Hyundai Veloster 2013. Boom. Yep, in fact, that's what it found at that point in the video, right? So now I'm starting to do some really powerful stuff through the web browser itself with minimal programming time on my part. This whole demo, each one of these took less than 3 hours to write because there's so much stuff out there for me to utilize directly. All right. Where's the play button? There we go. Thank you. All right, these cool things exist. I'd love to use them. How do I find them? Right now, it's kind of a mishmash. There are a few sites out there that list and aggregate them: rapidapi.com, programmableweb.com, apilist.fun. Those all show you different algorithms, different APIs from different providers. The pain of that is that as you go to each provider, they'll have a different spec. So even though actually doing the call out to get the JSON and return it is easy, there's often a lot of structural information about what that JSON needs to look like. So you got to read through each provider and figure out what it is for them. But there's a ton of cool stuff available. Google API Explorer describes all of Google's publicly available APIs, which more or less have a very similar spec. So once you're in that ecosystem, it's a little bit easier to breathe. But often you'll still want to cross things from different providers. Now, if you want to do that in a way that doesn't require much back-end programming at all, one option available to you is these things called API connectors, right? So IFTT, Zapier, Automate.io, right? You can use these to access different API providers. So I can do something like from my browser app, I can fire a webhook. Automate.io will notice that webhook, and it's going to trigger something to occur on Twilio to send me an SMS, something to occur on Slack to send me a message right in my Slack channel, or I can have it, say, sitting and monitoring my Gmail, and whenever a new message comes in, it does that same pathway. So now I can take all these different APIs from different providers, and with fairly little effort, mostly these services have web-based kind of connector tools. I can hook them up together. Okay, so that's one way to do it, but what if I actually want to code, not just deal with somebody's UI? Then I want to start thinking about building and hosting my own APIs. So I'm going to do this for a few different reasons. One of them is just to get code off of my client to be able to scale it and to be able to secure the code, right? Because once that code is out there on an API provider, someone can't just look at the source as they could with anything running inside my browser, right? I want to be able to perhaps standardize my code and support multiple different clients so I don't have to be porting my code across points all the time. And I want to avoid all of those pesky callbacks and waits. So this is the one place where I did write a little bit of server-side code where I was showing you that video transformer, right? So the image colorizer, that's one algorithm that's out there. That's one API. I could accept the video inside the browser, break it out into individual frames. That's possible, though difficult. Send each of those frames individually, aggregate all of their results, and then give back some video. The transport time alone, just for taking all of those individual images and sending them back and forth, is absolutely going to destroy my user experience, right? So what instead I'm going to do is I'm just going to take that one little bit of code, I'm going to move it out to a server somewhere, but I'm still going to utilize all those other APIs. So now it's one call from my client, go and do this thing with the video on the server locally. It can break that up, reassemble the video quickly, hand it back to me. So I've avoided a lot of wait time for the user. Similarly with callbacks, if I'm doing something like scraping a website, first I'm looking at a page, I'm getting all the links, and then for each of those links I'm doing something else, and before I know it, I've got a callback chain that's 50 deep. And that's just exceptionally painful because I've got to wait for all of those to unwrap before I can provide the user something. Again, put that on the server, easy, low wait for the user. But the other really nifty thing about starting to build and host your APIs is making them available for other people to use. So I'm not just programming in a vacuum, I'm actually going out there and giving back to the community. Akin to taking my library I've built and putting it up on GitHub, sure, but now I've made it really low effort for anyone to go and use. I've got that wrapped up as an API, and I'm like, go just use it, and that person doesn't have to pull down, integrate the repo, et cetera. They can just immediately execute the stuff that I've created. Pretty much what I was talking about with aggregating stuff into a single call. All right. So what are your options for going and building and hosting your own APIs out there, right? Well, you could roll your own, right? I mean, you can start up a Flask server. You can put it into, say, Google App Engine, and you can have it out there, and you can build out your API on your own or from many of the frameworks that are available. That works. You have to think pretty heavily about designing that API and the complexity of that. Some people have tried to make this a little bit easier by creating these API portals or gateways. And what these do is they hook into your existing code base, but they act as a layer on top that deals with all of the making it API-like. Everything from the JSON transformation, data transformation, to scaling and caching and all of that. So your code is still running on your server, but these things are connecting to it, and other people are connecting to those APIs. So it's kind of an API proxy, but it adds some benefit as well. And then what I think is really the coolest place to go with this, which is this serverless API hosting, right? So AWS Lambda, Google Cloud Functions, Azure Functions all fall into this category, where you're writing relatively small bits of code that are going to be independent and portable, and their ecosystem, their machinery takes care of all the scaling for you, as well as the execution itself. So I write the code, it's perhaps registered under my account, but it's out there. Anybody can call that API if I give them authorization to do so, and the service provider takes care of all the scaling and all of that, right? This makes things really, really fast and easy to use. Things you want to think about as you do that, just some considerations. Do your providers, whether it's a role your own or whether it's using one of these cloud-based services, do they support full concurrency? Do they have limits on the execution time that's allowed? So Lambda, for example, has a fairly short window in which your function must complete and return, or it just kills it. And that's one of the things you want to think about as you use those services. How much memory you're allowed to use, what's the overhead latency of that particular system. It's going to be heavier with those proxy-based systems than it is with the cloud providers, for example. What languages do they support? Now, the really good thing here is that just about every provider out there supports Node, right? So you've got some function you've written, whether you're running it in your own Node server or you're running it locally in the browser, it's more or less cut and paste for you to take that thing and to put it into some kind of cloud-based function. Great. What kind of libraries and dependencies do they support? Do they have GPUs on their server if you're doing some machine learning or visually intensive processing? Do they, out of the box, support logging, versioning, authentication, all these things you normally have to wrap around your stuff? All right, and at some point you say to yourself, okay, so that's all well and good, that's powerful stuff, but aren't you just building a server, John? Isn't this just back where we were about having to write a back end? And it's not, because there's a different purpose, right? What we're talking about here is we're creating general purpose APIs, things that are independent, things that we can use, but things that other people might be interested in using, things that can be created into mashups with other APIs to create useful long chains. So we're not just building like a single purpose thing or a basic CRUD backend where I'm going to store my data and retrieve it through an API. No, what we're doing here is we're building Lego blocks. We're building things that we can make and other people can make, and then we can stack them together, and then it makes this really cool thing that just executes out there and returns an awesome, useful combined result. Right? And the sort of holy grail of this is what can you do in terms of having basically the same API call, whether you're calling locally into your own function, whether you're calling from a client to a server, whether you're calling from one server to another. If you have multiple API authors, can you still get to them all through the same API interface, possibly the same server machinery? And how can you discover other people's APIs? How can you make your own APIs available to other developers? So there's lots of different ways to satisfy this. A lot of it is roll your own kind of stuff. And this is where I mention my favorite tool for doing this now. Admittedly, I'm a little biased because I do work for them. But in my defense, the reason I work for them is because I discovered they could do this, and I'm like, that's so cool, I want to work for you. So here's what they do. They act as a general service API provider where there's about 3,500 algorithms in there. There's one spec for running all of them, even though the data is different on each one. They act as an API host and a gateway. So basically, you go in there, you take some code you want to put in, you wrap it in a single apply function, and then it's immediately available as a JSON endpoint to anybody. And there's a marketplace. So I can say right inside the system, this is the cool thing I built. This is why I think it's awesome and you should use it. I can also go out there and I can search for like, okay, who there has good models already available for sentiment detection or natural language processing or image colorization and glue those right into my application, and they all run internally so I can create these nice deep chains. So what I encourage you all to do is, whether you're using this or some other system, as you go out there and you build your APIs, think about, what am I satisfying? Is it just me? Is it just this particular product I'm trying to build right now? Or am I making something that's going to be general purpose to the community, that's going to be out there, that other people are going to be able to touch and use? How am I going to broadcast that fact? And how am I going to keep that in mind so that as I build the API, I'm not just going to make it usable for one particular set of conditions, but I'm going to add enough parameterization, enough general usability that other people are going to want to take that and use it. And that's going to just make things more and more awesome for all of us, so we can continue to build these really cool applications really quickly without tearing our own hair out trying to build everything from scratch every time. If you want to get in touch with me, I'm Peck John on just about everything, Twitter, LinkedIn, GitHub, etc. And I pasted the slides link into the Slack channel. Also, when they found out I was going here, Algorithmia sent me a promo code that they wanted me to send to you all, so feel free to use that, of course. That'll get you $50 of credit in the system. Otherwise, go forth, build awesome things. Please tell me about them so that I can use them too, because I think it's a wonderful world we're all living in now. Thank you.